Hey everyone, and welcome to the Tom's Hardware Podcast for April 13th, 2021 already. As always, I'm Tom's Hardware Editor-in-Chief, Avram Pilch, and I'm joined by Associate Editor Les Pounder, Raspberry Pi expert Ash Puckett, and today we have a very special guest, Nathan Seidle, the founder of SparkFun Electronics. Hi, Nathan. How are you doing?
Hey, doing really good. Thanks for having me. Yeah, it's a pleasure to be here.
So, before we get started with the latest stuff, can you tell us a bit about SparkFun Electronics and how it got started and what you guys do?
You realize you're basically asking a nerd about his project, right? I could talk forever about SparkFun, but SparkFun is a company I started 18 years ago. I joke that I've never had a real job. I was shipping stuff out of my bedroom in college, and it just continued to grow and grow and grow.
Are the rest of you guys on?
I'm here. I think I see a frozen screen.
I think Nathan froze there.
Uh-oh.
Uh-oh. How about you, Les? Are you frozen?
I'm here, don't worry.
Okay. Well, wait a second. Hopefully Nathan will come back.
Murphy's Law. Murphy's Law.
Oh, wait. So you were saying you were talking about how you started SparkFun 18 years ago.
18 years ago, I was in a bedroom going to college and decided I'd start a website and sell some stuff to some friends in Colorado. And I think it was my seventh order was from France. So I never took a class in college about how to ship stuff to France, but that day was the day that you realize, somebody wanted something, they paid for it. Now I figure out how to ship stuff. Fast forward 18 years, and we've got 2 SMD lines. We're going to talk about some boards today, but what you see from SparkFun, these boards are actually manufactured right here in Boulder, Colorado.
Oh, cool.
So, yeah, if we ever get the chance again to travel and do tours and things, by all means, please come to Colorado someday, and we'll show you how we design and manufacture electronics.
Yeah, amazing. So what are those boxes behind you?
Oh, so funny story. This is sort of the video wall, right? This is where we do a lot of our YouTube videos and product demonstration videos. But the red boxes is sort of, it goes way back in time. So when SparkFun first started, I was super cheap. I would use recycled boxes or I would use brown boxes, and it worked, right? As long as the thing gets to the customer, I didn't think it mattered. And we were just getting big enough that we hired somebody in marketing, and she came to me and she was like, Nathan, I have this idea. Let's do a red box. And I said, that's a great idea, but how much is it going to cost? And she said, well, it's about double. The box was 20 cents. The red box was going to be like 35 cents. I was like, no way can we double our box cost. That is insane that you will put us out of business just on boxes. And she was, she kind of talked me into it. And so we did this short run of, I think, 200 boxes or something. And as soon as we got the boxes in and we folded one up, I went, oh, this is really nice. And we shipped them to customers, and everybody was so excited when that little red box showed up on their front doorstep. She was completely right, and I was so wrong. And from that day forward, we've always shipped SparkFun orders in red SparkFun boxes, just because, they make really good enclosures. So people cut out holes and put their electronics inside and then run the cables inside. So a brown box is something you recycle, but a SparkFun red box is something that people hold on to. Shoot, I might have it. Hold on.
Oh, how cool.
So this is my parts box. So this is the box that I have all my junk in whenever I walk around with my backpack. And as you can see, it works. It keeps all your stuff in it, but I might need a new box.
It's a little broken in.
Yeah, well loved.
So SparkFun has been a real leader in a lot of things, including Raspberry Pi, and now you've got a bunch of RP2040 boards. What do you think of the RP2040 platform, and why did you choose to invest in it?
So when Raspberry Pi came to us fall of 2020, they said, hey, we've been doing these single board computers for a long time, but we've designed our own chip. And we went, you did what? And it's what Atmel does. It's what Microchip does. It's, people, very, very large companies are doing silicon, not small companies. We say, okay, Raspberry Pi, you're big, but what are you doing? And they started to sketch out what they had done, the dual core M0 running at a fast clock rate. And it was all kind of interesting. And then Eben started to tell me about the PIO. So the RP2040 is a unique microcontroller, but what really kind of tickled us, what we got really excited about, was that PIO interface. And I could rattle on about the PIO if you want, or Les could probably tell us more about it.
Yeah, I mean, we certainly have seen some really interesting projects with people taking advantage of the PIO. Les, what are some of the ones that you've seen where people are really taking advantage of it?
It's the retro computing scene that I'm most impressed with on a Pico. A $4 microcontroller emulating a BBC Micro from when I was a kid. ZX Spectrum as well we've seen now. And just being able to do all this wonderful stuff with such cheap hardware. I mean, you need some sort of carrier board to break out the DVI or HDMI and sound, that sort of thing, VGA.
Yeah.
But it's still, the heart of it is still this tiny chip, smaller than my thumbnail, that costs $4. And that's insane when you can think of the computers of that era, where, BBC Micro was about £400 back in 1980s.
That's real money.
About £700. That's a lot of money. But now you have all these crazy projects being powered by. So we have, the retro computers. We have what's it called? The Orange Pi, I think it is, or Pico, Orange Pico, something like that.
Okay.
Where it's a full computer which runs a Python interpreter that you boot into.
Yep.
It's like it's mad.
I'm a microcontroller guy. I'm an electrical engineer through and through. Looking at the data sheet, it's like, okay, it's an M0 running at some frequency. Okay, it's dual core. That's interesting. But the PIO is the weird thing to me. So this microcontroller has all the standard sort of. It has a couple UARTs. It has a couple SPI ports, I2C ports. That's all pretty normal. The PIO to me was the thing that really stood out, because that was I describe it as like if you can't, we were talking about neopixels before. If you need to drive an addressable LED, how do you do that? There is no microcontroller that has a built-in hardware interface to drive addressable LEDs. The PIO is this flexible thing that you can program it so that it's like a separate core that just does a unique hardware interface. So if you want to talk to SDIO, this chip doesn't have SDIO built into it, but it has the PIO. So you can program the PIO to talk to SDIO or addressable LEDs, or we were talking DMX before. I think DMX is just serial, so you could use a UART, or you could throw the PIO at it. And we mentioned earlier, there are some wacky people doing HDMI. This microcontroller can output HDMI. It's not supposed to. You have to overclock it a little bit. But like I said, that really smart people using that very flexible hardware in a way no other microcontroller has. So I don't know. The RP2040 is very unique in that aspect.
Flexible is a good word to use for it there in that regard.
Ash, what are some of the coolest RP2040 projects you've seen so far?
That I've seen so far?
Yeah.
I don't know. You have to go look at the best Pi projects list to find that out. But I don't know. One of my favorites that I saw was somebody had made a controller that used an accelerometer. It was a Pico with an accelerometer, and as they tilted their hand forward, it was working like a controller in a racing game. And their car would go forward, and they tilt it to the side, and they would veer to the side, and they would tilt it back up, and it would slow down. And it just seemed so neat. You can make VR controllers with a Pico. That's awesome.
Yeah, that's my ambition that I still haven't fulfilled yet, is to make an RP2040 powered game controller, because I've tried a bit. CircuitPython has the HID library. It's sort of it works to an extent, but I couldn't get it to be recognized by anything but like my PC. I couldn't get it to be recognized by a Switch, and I couldn't get it to be recognized playing PC games yet. And now my goal is shifting. I'm trying to get it to do it with BLE, but not there yet either. But what I really like is the potential to use this for peripherals and other things that you just turn on, because it's always on. And I really like using CircuitPython and MicroPython. I like it better than using Arduino. I think this is a real step up from not only from using programming Arduino, but the amount of power and flexibility that you have with the typical Arduino board. So, my son and I, when he was like 5 or 6, we were doing Arduino stuff, and we're like, we graduated to Raspberry Pi. We're done with that. And then the Pico came out. It's like, oh, well, we can program this more like we program the Raspberry Pi. We can use a version of Python. So now we're doing a ton of projects like that. So speaking of things, the RP2040, SparkFun has 3 different RP2040 boards, including, I think, the most unique one we've ever seen, which is the MicroMod. So what can you tell us about it?
Yeah. Boop, 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 boop. Let's see if I can hold that up there. MicroMod. So that's the RP2040 in the middle. And then on the back, we've got 2 ICs. One is the external flash. We use a 16 megabyte external flash, which is like way overkill, but really helpful for some larger projects. And then the smaller IC right there is a USB switch. So the RP2040 is unique in that it can act both as a host and help me out, a USB device and a host. So when you attach it to your computer, it looks like a mass storage device, and you just drag and drop new binaries onto it. It can also act as the host itself. So we can interface the RP2040 to things like keyboards and wireless mouse and thumb drives. A lot of that support is coming, but host mode is working. So the MicroMod is this format that we came out with about 6-9 months ago. And all of our different processors have the same M.2 interface. And then we have a series of development boards that have that same M.2 connector on it, so that you can change out processors to whatever you're trying to do. RP2040 is really nice, really flexible, does not have any radio built into it. And so if you need to do something like Bluetooth or Wi-Fi, there's the NRF series to do really powerful Bluetooth, and the ESP32 to do BLE and Wi-Fi. But yeah, we've got a series of different MicroMod processors, and then I think we're up to like 7 or 8 MicroMod carrier boards, including weather and display and machine learning, all sorts of fun stuff.
Wow. So does this work with all of the existing carrier boards?
The RP2040 MicroMod works with all the pre-existing carrier boards. Yes, that's both it's a fun little challenge actually to make sort of new hardware work with old hardware. But yeah, you just screw it down and you've got all the connections to all the pins around the edge. This is the ATP, or the all the pins carrier board. And you can see you've got the USB A connector for things like I mentioned earlier, keyboards and thumb drives and things. So.
Oh, great. So Les, you've actually been messing with one of those recently, correct?
I have, yes. I've been messing around with 2 of SparkFun's boards for the RP2040. I've got to the overhead camera so you can see what I'm doing. So I'm lucky to have the MicroMod board. Here we go. Hold it up to the right camera. Always works. There we are. And it fits into the carrier board. Just an M.2 slot. Fits in, and I screw it into place, and I've got all the pins broken out. And I'm amazed with the MicroMod because there's 75 pins on there, which is more than what an actual Pico has 40 pins. So I'm just wondering, the extra 35 pins, what are they doing?
I'd have to go look at the pinout one more time, but the Pico was specifically designed not to break out all the pins on the RP2040, but most of them. So we did have the advantage that the IC itself had more GPIO. And so we just took advantage of that and broke that out to the, like you said, the 75 pins on the MicroMod interface. What are you building with it? You had some cool stuff there.
I've been messing around. It's what I like to do to learn stuff. So normally the thing to do when you get a new board is to blink an LED. So I took it a stage farther, and I've got now the Pro Micro version on a breadboard, and I've got a pretty simple, almost like a Larson scanner going on there. Try so you can see it there, and it's exceptionally easy to build. I mean, obviously it's a simple circuit. It's just connections to the pins here. So I've got 9 pins on this side, 8 pins on that side, and 2 more over here, and all works really well, nice and easy. Pins are well labeled. I do like that on the board. I do like pin labeling. As much as we all want to be, you know, a ninja of some sort, who just goes, yes, I know exactly where GPIO 17 is. we do need the reference there, because there are times we'll just go, I have no idea where I'm putting this. So
that's a major problem with the Pico, by the way. The fact that the pinout is on the bottom. The first one I got, I deliberately put the pins upside down so that I could read it, and I came to regret that. But I really wish that they had the marking on the top. That's a huge improvement.
Yeah, well, and SparkFun boards have got the marking on the top. Obviously, the MicroMod, it's too dense. It's broken out to the ATP.
Yep.
So that's useful. But I've been programming this a little bit differently. So normally we go for something like CircuitPython or MicroPython or C and C++. But I did something a bit different. So recently, that's a couple of days ago, Arduino released the official core for the Arduino IDE. So I've used that official core. Let me just go to the Arduino screen so I can see what I'm doing. It's hiding. Okay, so it just appears as a. So I just go to the board manager, type in Pico. The official embed library is there. I install the board, select the board, select the port, write normal Arduino code, and then just send it over. So all this code here is in screen now. It's just a for loop that iterates over an array.
Les, we see like all of your screens. Can you zoom in on the Arduino one?
Oh, okay.
There you go.
I think I've had a crash. 1 second, sorry.
It happens to the best of us.
Yeah. I can't see what you're seeing for some reason. There we go. You can see my screen there.
It's so nice. I myself I use Arduino every day. I'm not much of a Python user, and so it's really nice to have that built-in Arduino support. Raspberry Pi did not support Arduino from the get-go. They're really kind of betting on the Python frontier, and I think they're betting in the right place. But there's still, tens of millions of people using Arduino, and it's being taught all over the world alongside Python. So it's good to hear that there's also Arduino support for it as well.
The Arduino support, I think, is a game changer now. So we've had MicroPython, CircuitPython, and that's the best way for new users to come into a board such as this, and for programming in general, really.
Yeah.
So there's loads of support out there. But if we want to do something that's a little more advanced, something almost bare metal, something faster, that's what C and C++ is all about, speed, really.
Yeah.
Getting into C and C++ with the Raspberry Pi Pico documentation is possible, but you need to have a good grounding and knowledge of how everything works to go through the process. So with the Arduino IDE, we get the speed and power of C, C++, because it's a dialect of that, pretty much.
Yep.
But we get the ease of use of the Arduino IDE. So a $4 microcontroller and a free open source piece of software that's been around for years and has thousands and thousands of tutorials is a complete win for me.
Yep, I'm in the same boat, and you said it really well. You said it very diplomatically. The support for C and C++, their SDK is great, but it's very much written for professional C developers. And even someone like me struggled to get the SDK running. With Arduino support, it makes it so much easier. So yeah, that's really good. And then Les, I see you've got, I think there's a Qwiic accelerometer on there. Have you got a chance to use any of the Qwiic stuff yet?
Not as yet, no. I've been keeping it simple while I learn the basics of the board. But I'm familiar with Qwiic because it's very similar to Adafruit's Stemma QT connection. So I'm familiar with how all the things connect together. It's almost like electronic Lego, for want of a better phrase. It just plugs in. I haven't got to worry about the electronics. And I started electronics properly for fun and profit 10 years ago. And before then, I only dabbled. And the challenge for me at the start was the electronic wiring. So making sure that the wiring was tied in, I knew where things were and what they were doing. And then learning the code and how to control it. And it wasn't an easy process to start with. There were a few mistakes, and there's still a few mistakes to this day. We've all wired it up wrong before now.
For ages and ages. So I2C devices have a clock line and clock and a data line. There we go. And you knew it's clearly labeled on boards, but if you've got a breakout board with SDA and SCL and power and ground, you've got to get those 4 wires to the right part of the board, and you got to strip the wires and solder the wires, and you get them. I always got the clock and the data mixed up, and so me and a couple of my coworkers, it was in 2017, we were like, could we just solve this? Could we just put a polarized connector on it so that you can't plug it in the wrong way? And we did, and we came out with this Qwiic thing. And so here we have, this is the RP2040 attached to the 4-meter LiDAR. So this shoots out, VEXEL is the coolest thing ever. What is it? Vertical cavity surface emitting laser, VEXEL. So this thing shoots out an infrared laser, bounces it off of a surface, and then times it, time of flight, says that you are, 256 millimeters away or whatever. It's I2C, and so we can put Qwiic connectors on our main boards, we can put Qwiic connectors on the peripherals, and you can see a second Qwiic connector on that. It's a bus. So we can chain together 4, 5, 6 things, and I haven't turned on my soldering iron. I haven't done any kind of figuring out the wiring. I just plug it all together. A couple years after we came out with Qwiic, Adafruit came out with Stemma QT. And theirs is very similar. I think they tried to make it 5-volt compatible. I don't know how many of their products are actually 5-volt, but it's the same as Qwiic. So because of the number of Arduino libraries we have for all of our products, both in C and in Python, we're trying to make it as close to Lego as possible. I do not. Lego is amazing. We're never going to be a multi-billion-dollar company, or as good as them. But the ability to plug stuff in, not the wrong way, is a really powerful thing.
Yeah, that's amazing. So Les was showing the boards that he's worked with. So we have the MicroMod. What are the other 2 RP2040 boards that you have?
The Pico and the Thing Plus, and I'm going to have to wave the Thing Plus around because we shipped them all out. But the Thing Plus is based on the Adafruit Feather. So Adafruit has this feather design that has the pins in the very specific positions. We riffed on the Feather footprint and created a thing, whatever. It's got USB-C and it's got battery charging and it's got a Qwiic connector on it. And so that is the RP2040 Thing Plus. So if you need lots of I/O and you have some Feather shields.
So it's Featherwing compatible?
It's Featherwing compatible, yes.
I happen to have a RP2040 Feather right here. So this is
nice.
Because what my son and I really like about the Feather is the ecosystem, of wings, because you can get the airlift, which is I have right here actually, which is the Wi-Fi board, and you get the little joystick one. So this is what we're using to try to create a Bluetooth joystick. So that's really neat to be able to interface with that ecosystem.
Yeah.
Yep. And then the last board is the RP2040 Pro Micro. So this actually comes from a design that, what did we do? It's probably 8 or 9 years old at this point. Was based on the 32U4, and before that, it was based on the Arduino Pro Mini. So this is actually pin compatible to the Arduino Pro Mini that is, 15 years old at this point. The main benefit to this board is its size. It's really, really small. It's got castellated pins, so you can actually surface mount this, reflow this onto your target. And we see a large number of users using I think it's the QMK firmware. It's a keyboard replacement. So folks that are doing their own keyboard builds often need a little microcontroller to live inside that keyboard and do all the, what is that called? Where they're monitoring all the different keys. So this is designed for that. And we've got a few boards in this footprint that do really, really well for that reason.
Wow. Fantastic. Yeah. I mean, I saw somebody use the Pico to build a mechanical keyboard. I don't know exactly how they did it, but that's pretty cool. I would love to build a full keyboard with one, but right now we have seen a couple of instances where I think Pimoroni has the keybow, and they have the keypad, where you're using RP2040 to power a keyboard. So, is there any? Do you have any other plans with RP2040 you can share? Do you think this is it for a while, or do you think you might be doing more with it?
Good question. This is probably it for a while. Where we are really pushed is the carrier boards. So now that we have the processor board sort of done, it's the future of carrier boards. So the coming soon to a store near you are carrier boards that have. Do you know the ZF9P? It's a really high precision GPS receiver. We've got some nice, fun GPS receivers coming, and then some new machine learning carrier boards that have just faster video feeds and microphone feeds, so you can do more of that machine learning stuff on audio and cameras.
How will you accomplish that? Will that be through TinyML?
Yeah, yes. We have a good partnership with Google and the folks at TinyML, and the work that they're doing on voice recognition and image recognition is just incredible. The math behind it is way above my pay grade. I cannot follow it, but there are some very smart people doing some amazing things. Yes,
Les just recently tested out. RGCam has a kit where they're selling you their 2 megapixel SPI camera, and have instructions for doing this. I tried to do it at home because I have the camera. Didn't work for me. Need a better tutorial or something. But what would you recommend for folks who want to use this? I mean, like, what would you recommend as a camera for that? What will you be doing for the video capture?
I mean, it really depends on where you want to start in the food chain, but Avram, I feel for you because you live at the forefront of like new hardware and reviewing new hardware, and it's all the. I'm not surprised that you're challenged to get a lot of new stuff working. I get the benefit of using it for a number of years until it's fully baked. Oh, I can't imagine what your job is like trying to make all this new stuff work.
It's fun every day, there's the stuff that I'm supposed to do during the day, and then there's like a certain point in the afternoon when I'm officially done with work and my 9-year-old is off school, and he comes into my office and he's like, "Hey, what are we working on today? Did you get it working yet?" So
did you get it working yet?
yeah, or and then I'll be like, "No," and I'll be like, "Well, let me try." So we'll try that one. He was disappointed because we were following the directions on, I think it was on GitHub or something, to get the SPI camera working with a Pico, and we couldn't, and it just the serial port, whatever, couldn't connect. Gotta try again. Sometimes you gotta try again. We couldn't get, for like 2 weeks, we couldn't get the firmware updated on this to do BLE on this Featherwing that we wanted to do BLE. Then I reflowed the solder on it, and I tried plugging it on one of the pads. I tried plugging it in again, and I was able to update the firmware. So, it's stuff like that. Although his main thing now is that he wants to do Make Code Arcade, is his obsession at the moment. So I'm hoping that somebody comes out with a way to use RP2040 for Make Code Arcade, because I know it doesn't have very stringent requirements. Greetings from Finland. Russell Davis says, recently discovered a RISC-V board based board that is Feather format too. Really nice, especially as I've been picking up Feathers quite a lot recently.
Yeah. That's another sort of chip contender out there that's doing some really crazy stuff. RISC-V is pretty exciting.
Yeah, it's great to see the variety. That we have. We have to do a guide on which processor is best. If you were to sum it up, Nathan, for microcontrollers, what processor do you like the best now, or what would you recommend to people?
I personally, it took me years to see the light. I'm way behind the curve, but my current go-to hammer for all my projects is the ESP32. So just the depth of tutorials and it's got Wi-Fi and BLE and Bluetooth Classic all in one. So for me, I do a lot of GPS stuff. And so I've got this RTK, this GPS receiver, and over Bluetooth, I can transmit serial to my cell phone. And the time it took to set that up was hours. It was incredibly fast to pull anything off with Bluetooth. And the power of the ESP32 is, in my head, is still just blows a lot of the other ones out of the water. Now, when you get into specifics, STM32 and STM32 is excellent for consumer products. If you're going to sell 500,000 of something, it's an STM32. If you are doing 1 billion hard drives, RISC-V is the way to go. Right? Western Digital is going to move all of their ASICs to RISC-V over the next 5 years. It's an incredible switchover in a very short amount of time. So I don't know. Every microprocessor has its niche. For me, for my go-to hammer is ESP32.
Sai says, but ESP32 is not exactly designed for low power performance.
It's terrible. Get a bigger battery. No, you're absolutely right. The ESP32 is a power hog. There you go. It's sort of whatever your target application is. My particular application, this RTK Surveyor product, has a 1 amp hour battery in it, so I can run my product for about 5 hours in between charges. And for surveying, when you're out in the field with a stick and you're moving around, 5 hours is an eternity, and so that's completely adequate. But if you need a watch, right? You're not going to use an ESP32 in there. You're going to use a Gecko or some sort of. We have a product called Artemis that's based on the Apollo 3, which is like 6 microamps per megahertz. It's incredibly low power. You can run things off of a coin cell for years. It all depends on what you want to do. But yeah, that is one of the downsides of the ESP32. I've seen folks getting it down to like 10 microamps. So it's possible, but it's not a low power microcontroller.
Speaking of controlling things, Ash, you had something that you discovered that you were messaging us about before, which sounded really cool. So I just wanted you to talk about that. Something that really takes advantage of touchscreen on the Pi.
Yeah, so I like to use OBS while streaming because it's free and open source, but I wanted to make things just a little bit easier to manage while live streaming. So I decided to use an application that we previously featured on Tom's Hardware. It's a Pi project, and it's called StreamPi. It was created by a couple of developers named Samuel Quinones and Debayan Sutradar, and I hope I'm pronouncing those names correctly. But you can read all about this project on tomshardware.com. I thought it would be fun to show a live demo of how it works. So, according to the developers, the idea was to create a Raspberry Pi alternative to the Elgato Stream Deck. And that works as, I don't know how much it costs, but I know it's a little device with a touch screen, and you can program the icons so that when you touch the icon on the touch screen, it triggers a function on your computer through something like OBS. But why would you pay hundreds of dollars for something that you could just recreate with a Raspberry Pi? So behind me, I've got a Raspad 3, which I chose to use because, well, it has Raspberry Pi 4 inside, so I know it's running, the latest hardware. And also it has a touch screen, which is fantastic for what we're trying to do. So on my Windows computer in front of me is a server. On the Raspad is a client that's running, and I had to link those two together, and I had to link OBS to the server client on my computer, and whenever I touch one of these icons on the Raspad, it's going to change the scene in OBS. So I want to make sure that I have everything open right and it works correctly, because we're having good luck today on stream. So if I touch this, it should switch to the Raspberry Pi screen, and that you can see what's going on the Raspad. If I touch the icon on the far right, it'll switch to show you the camera and the Raspberry Pi at the same time.
Hey.
Very cool.
Yeah.
And I also pulled up VNC on my phone, so if I don't want to turn around, I can just tap it over here.
Ooh.
Yeah, pretty
Nice.
Cool.
So we need to use this more often. It's way too fun. You guys have to check it out. And it doesn't just integrate with OBS. That's another benefit of using the Pi instead of buying proprietary software, is people are adding on to this all the time. It can integrate with Twitter. I can hit a button. Sorry if you hear the train outside. I could hit a button and you could have maybe a train go by the screen when your train goes by outside. You could hit a button and you could have a tweet come out in real time. There's all kinds of different apps that are planned to integrate in the future. But right now, OBS and Twitter are a thing. So you can have a lot of fun with that.
Great. So speaking of regular Pi, Nathan, is there anything new that you guys are doing with traditional Pi that we should know about?
No, all the standard sort of accoutrements. So we have the kits and the starter kits to get you going with Raspberry Pi. What I find really fascinating from the Raspberry Pi front, a lot of our customers are beginners, but we're selling a tremendous number of Raspberry Pi to near as we can figure industrial clients. So there's it's such an interesting sort of community of people putting, Ash, as you pointed out, sort of using Raspberry Pis for more and more industrial consumer product, consumer facing things. So to me, it's less about sort of the types of Raspberry Pis coming out and more about what people are putting them in. So Ash, to kind of speak to that, the OBS sort of interface you described, I was talking with a friend the other day at the Open Hardware Summit that open source hardware is also nicely preventative against obsolescence. So we've seen so many startups go out of business and their proprietary hardware is sort of locked. And when that business goes away, the device in your hands is basically dead. You can't do anything with it. But with open source software and open source hardware, we can reprogram these devices. If I had a Raspberry Pi that was my touch interface to control that industrial piece of equipment, I don't care who goes out of business or what happens, that product and that interface can live on. And so, I don't know, I'm a big proponent of open source hardware and open source software in order to sort of keep things from immediately going into the landfill.
Yeah, no doubt. I was going to pull out a certain smartwatch I have in a drawer over here.
Is it a Pebble?
Yes. that I wish was open source. That I wish was open source hardware.
I heard they saved it at the midnight hour, didn't they?
I think there's a. I haven't really messed with it, but I think there's a third party party firmware that you can get for it. But yeah, open source is the way. So we have one more question, which is Abe asks, how many icons can you make? Ash, do you know the answer to that?
That's a good question, and I can't pull up the exact number, but you can specify how many columns, how many rows you want. And I had it set up earlier with like 5x3, so you can set up quite a few, and you might just be limited to how big your screen is. You can also adjust how big you want the. Let me switch over. Hey, let me hit the button. Oh no, accidentally closed the server on accident, so it's not running. But you can adjust the screen size. So let's say you have a touch screen with like a really weird ratio. You can configure it to either run full screen or in a windowed mode into a smaller window. So you can.
Great. So where can folks go to learn more about how to do that for themselves, Ash?
If you go to the official StreamPi website, let me pull it up. I think there's a hyphen in it, and I want to double check for you. Yeah, it's stream-pi.com, and they have download links. The instructions are out of date, but there are links to their GitHub page, which has more up-to-date steps on what you need to do to follow along. So check the GitHub rather than the website for instructions.
Yes. And where can folks go to learn more about your SparkFun's new RP2040 boards and other products?
SparkFun.com/RP2040, or just Google SparkFun RP2040, and that you'll find it.
Great. Well, thank you so much, Nathan, for joining us. This is really exciting and honor to have you on. Thanks to everyone who watches and listens. As always, you can find us on YouTube or Facebook after the fact, and you will see us here at 2:30 p.m. Eastern, 7:30 p.m. GMT on Tuesdays. See you all next week. Bye, everyone.